Welcome everybody to the Homework 10 review videos. Woohoo! Everyone's watching this one. And it should be the first one that everybody watches. Because I want to make sure with problems 1, 2, 3, and 4, the actual, problems with the numbers 1, 2, 3, and 4, I want to make sure you guys actually understand those. So let's dive in. So this has to do with finding unique triangles. This is in reference to the the separating triangles notes page that we did, or that you copied from someone else because you were absent. So keep that in mind as we move forward. So the problem says a triangle has an angle measure of 90 degrees, angle measure of 20, and a side that's 6 units long. The 6 unit side is in between the 90 and the 20 degree angles. So it says sketch the triangle, label your sketch with given measures. Okay, so with this sketch, I didn't really expect perfection. So you can really, draw the triangle however, whatever. All I need to see is the 6 unit side, the 90 degrees, and the 20 degrees. So there's my 90. That's going to be my 20 degrees. And then my 6 unit side has to be between the 90 and the 20 degree angle, which means between the 90 and the 20, this side that they both touch has to be the 6 unit side. So this could have been one way to draw your triangle. You could have also drawn it like this, with that as your 20 degree angle. I'm labeling it on the outside because I can't write that small on this computer. So that would be my 90 degree angle, that would be my 20 degree angle. So the side that they are both touching, that is between them, I had air quotes there, but you obviously can't see them. So the side that they both touch is the 6 unit side. So as long as you have a sketch with a triangle with a right angle, a 20 degree angle, and a side length of 6 that is between them, you got it right. Yay, gold star for you. Okay, so the second question, though, is where it gets a little more interesting. It says, how many unique triangles can you draw like this? Now, unique meaning that that you can only make one type of triangle with these specifications. So how many unique triangles can you draw like this? You can actually only draw one, and let me show you why. So yes, you can have a triangle like this, yeah, and if that's my 20 degree angle, then this would have to be my 6 unit 6 side, because that's the one they're both touching. All right, so let me see. Any way I rotate this triangle, whether it's like this, or if I completely mirror it or whatnot, these will all be the same triangles, because that is how the triangle is set up. Now, the only way that you will get a different triangle, that you could make more than one unique triangle, is if, let me see, I want to erase those. Those were the best sketches. Anyway, so the only way you can get a different triangle is if you change where the angles and the side are rotated, or you change the order. Those of you who were here would remember me talking about the order, hopefully, because I can have a triangle that's like, all right, if I have a triangle like this, and if I have that 20 degrees, if I have the 6 unit side on this side instead of the side that both the angles are touching on, this is technically a different triangle. So then, because probably if that was 6, that would probably be 3, and then that would be something else. Whereas on your original triangle, you'd have 6, and then that would probably be 12. So very different triangles. All right. So you can only actually make one triangle here that has, with these unique specifications. It is because it actually says this. I just crossed out all the words I wanted to outline. Okay, because it says that, That is why you can only make one unique triangle. All right? I want to mention one more thing though before I go. Let's see, which color am I looking for? Okay. What I want to share before I go though is more about this order that I was talking about. The order is what specifies triangles that are identical. The same triangles will have the same order. And what I mean is, let's say I had this triangle. And this is an angle, and that's another angle, and this is a lovely side. So let's say this side was 5. Let's say this angle was 30. And let's say this one was, looks almost like 90. I don't know. That's probably not accurately drawn at all. But anyways, so the order that I would say for this triangle, I could say, okay, I have a 30-degree angle, I have a 5-unit side, and I have an 80-degree angle. So that is the order that the information is presented in. So now let's see if I had, oh man, on the spot. Okay. So if I have a 30 and 80, and that's where my 5 is. So if that's my triangle, my order that I would describe would be 30, then I'd hit my 80-degree angle before I hit my side of 5. So these two lists of angles and numbers and whatnot, those are in a very different order. Now, let me just write it like this though. Oh, wait, that's not what I want to do. That's exactly the same. Okay, so if I wrote it like this though, so these two are the same order because you're going from one direction to get to the other, whether you're going left to right or right to left around the triangle. Those two will be the orders you get, so those are going to be the same order. This one is different though because they are arranged not only in like a different order as you see them, like the 30 and the 5 are actually next to each other in that one, but the relationship between the different angles and the side length are going to be different. So this is probably a really poor drawing. If you look back on your notes, the separating triangles page, hopefully you can see a little better about why, the order does matter. The order is what determines which triangles are the same and which are not. Specifically, look at the third and the fourth set, the ones where you had a side and 2 angles and an angle and 2 sides. Look at those and see how many different triangles you can make that you indicated different triangles in different colors. But yes, look at those triangles and see how the order, of the angles and the side or the relationship between them determines whether or not they are the same triangle.